Today's lesson, we're going to take a look at similarity statements. We'll look at statements of proportionality and trying to prove that triangles are similar. So again, a similarity statement that looks something like this is basically just saying that this triangle is similar to this other triangle. What that means is that the corresponding angles are congruent. So I'll just write this: the corresponding angles A and D are congruent, the corresponding angles angle B and angle E are congruent, and angle C is congruent to angle F. That's the first part. The second part of the similarity statement is basically going to tell us that the corresponding sides are going to be proportional. So that means AB over DE is going to equal BC over EF is going to equal AC over DF. And now I'm getting all of this from this statement right here. I haven't even looked at these triangles yet, but those triangles should verify, should definitely say that these are the things that I have matched up. So it is decide what sides match up and write the ratio with the vertices in the correct places. So here are the angles, and here is the statement of proportionality. How do you know these figures are similar? There's two parts. One, that their corresponding angles are congruent, and two, that the corresponding sides are proportional. Those are the two parts that we have to look at whenever we talk about angles, similarity. Write a statement of proportionality and determine whether or not the figures are similar. So now we have to actually look at this shape here, and we might just say UV, and that's going to be related to the side over here, ST, and we'll ask, is that equal to, we'll say VW over, that's the long side here, that'd be SR, and we'll say, is that equal to, sort of the last side here, we'll say this would be, what am I writing here, WU over RT. What we'll do then is this is our statement of proportionality, and what we're going to do is we're not writing equals because we're not sure if they are equal yet or not, if they're proportional. We're going to test that. So how long is UV? Well, it's 4. How long is ST? It's 2. How long is VW? It's 12. How long is SR? It's 6. So I'm substituting those values in, and here's what I'm going to do in order to see whether these two are equal or not. What I'm going to do is I'm going to actually cross multiply. So 2 times 12 gives me 24, and that's going to be equal to 24. Since the two are equal to each other, then yes, these two shapes are similar. The sides are proportional. And then I can go through and I can go find something called a scale factor. A scale factor is this: if I take these two, if I take and simplify the statement of proportionality, I will get the scale factor. So that would be 2 over 1. This becomes my scale factor, which means that each of these side lengths are half the size of this, or each of these are twice the size of this one. So it kind of depends on how you set up your proportions to start off with, depending on if this is 2 over 1 or 1 over 2. Each one would be a scale factor. We'll do the same with this process here. We'll say PS over XW. We're going to decide whether that's going to be congruent to PQ over XY. Is that equal to QR over YZ? And is that equal to, finally, SR over WZ? What we'll do is we'll substitute some values in here. PS is 3, XW is 6, so that's looking good. SR, that's going to be this one over here, is 4, and YZ is 7. Excuse me. We'll cross multiply to see if these two are congruent. That'd give us 24 is equal to 21. Those two are not equal, so no, these shapes, these polygons, are not similar. Because they're not similar, you cannot write a statement of proportionality, you can't write a similarity statement, and you can't go ahead and write any scale factor. So that's what happens when they are, and when they're not, you can't write any of that stuff.